Preview.
Welcome to Valdymas College. This video is the continuation of the empirical formula, molecular formula, and structural formula. Here we have the first example from IJMBE 2003, number 14. The question is, an organic compound contains 62.1% carbon and 10.3% hydrogen. Now by mass, such that the vapor density of the compound is 29. Calculate its empirical formula and the molecular formula. To get this, to get the answer is very simple. So the first thing we're going to do is to write out our parameters, what we have. So the atoms present here, we have carbon, we have this of carbon, then we have this of hydrogen, then we have the vapor density of the compound. So firstly we have 62.1% carbon, then we have 10.3% hydrogen. Now then we have the vapor density of the compound to be 29. Okay, these are the three things we're given in the question, and we are asked to calculate the empirical formula. Now to get the empirical formula, we have to draw this table. Okay, so this table will be for the elements present. Then we have carbon, hydrogen, right? So now let's look at we are dealing with percentage here, so we have to look critically if everything is up to 100. Now if we are to add everything together, here we have 4, here we have 2, then we have 7, that is 72.4. It's not up to 100%, so that means the remaining element here is oxygen. So we have to subtract the 72.4 from 100 to get the percentage of oxygen. That is 100 minus 72.4. So we're going to have 27.6% of oxygen atom. So we are going to include oxygen now in our calculation. So here we have oxygen, carbon, then we have hydrogen, then we have oxygen. Okay, it's very simple. The first thing is the percentage by mass. Let's write out the percentage by mass. The percentage by mass is 62.1 given in the question. Then we have 10.3, then we have 27.6. Okay, so the next thing we're going to calculate is the number of moles. To get this, you have to divide number of moles is equals to the mass given over the molar mass of the atom. So the mass given are this, so we're going to divide it by its molar mass. The molar mass of carbon is 12, hydrogen is 1, then oxygen is 16. So now we're going to calculate the number of moles. So divide by 12. So you're going to divide this one 2 by 1, then you divide this by 16. So you're going to write out the answer to know what we have. Here we have, if you do this on your calculator, you're going to arrive at 5.175. Then this will give you back 10.3. Then here we're going to have 1.725, okay, from the calculator. Now, to get the mole ratio, you have to divide all by the lowest value. So you have to divide all by the lowest value. That is the next thing we are going to do. So the lowest value here is this. This is the lowest value here. So we have to divide it by lowest value. So we have 5.175 divided by 1.725. Then 10 divided by 3. 10.3 divided by 1.725. Then we have 1.725 divided by 1.725. So this will give us 1. Then this will give us 6. Then if you do this, we're going to arrive at 3. Okay, so now this is the mole ratio. This is the mole ratio. Now we can say the empirical formula is, since we have carbon, hydrogen and oxygen, so we are going to put the values of the numbers we've gotten. So you can say carbon is 3, then we have hydrogen to be 6 and oxygen is 1. So that is for question A. For question B, ask us to calculate the molecular formula. To get the molecular formula, remember the formula. The formula is that you have to the molecular formula is equals to the empirical formula times n. So you have to write molecular formula equals to the empirical formula then times n. Okay, so to get the molecular formula now, so we are going to write the empirical formula now in bracket is C3H6 or close bracket n equals the molecular formula. So the molecular formula now is, you equate it to the molar mass of the whole compound, and the molar mass of the compound is not given. We only have the vapor density. So the vapor density is given as 29. So there's this relationship between vapor density and molar mass. So vapor density is half molar mass. So if you multiply vapor density times 2, you're going to get the molar mass. So 2 times the vapor density will give us the molar mass. Okay, since we have 29, that will be 2 times 29. So we have the molar mass to be 58. Okay, now we are going to equate this to the empirical formula. So we have C3H6O, right, bracket n equals to 58. Okay, now carbon is 12, right? So that will be 3 times 12 plus 6 times 1. The 1 is for the molar mass of hydrogen, then plus here we have just 1 of this, so that will be 1 times 16 into bracket n. So if you do this separately and we add everything together, we are going to multiply with n, then we divide. So if you do everything now, this will give us 58 in the bracket. So 58n equals to 58. So if you do the sum of everything in the bracket, you're going to arrive at 58. So divide both side by 58. Divide both side by 58. N will give us 1. Therefore, we can multiply the empirical formula with 1 to get our molecular formula. So therefore, since our empirical formula multiplied by n will give us the molecular formula. Therefore, we have C3H6O into bracket n, whereas n equals to 1. So therefore, we have molecular formula to be C6, we have it to be C3, C3H6O. Okay. Now let's look at the calculation once again. From the beginning, I said an organic compound contains 62.1% carbon and 10.3% hydrogen by mass, such that the vapor density of the compound is 29. Don't forget, we are not given the molar mass of the compound. We are given the vapor density. To get the molar mass of the compound, you have to multiply this by 2. Okay. So calculate its empirical formula and molecular formula. The question is from IJMBE 2003, number 15. So we have carbon to be 2.1, then hydrogen to be 10.3. You have to check if it's up to 100 and it's not up to 100. That means the remaining compound present is oxygen. So then the calculation, you have to create a table for it. So carbon, hydrogen, oxygen, those are the elements present. Then the percentage by mass of the compound, we have 62.1, 10.3, and 27.1. To get the number of moles, the formula is the mass over the molar mass. The molar mass of carbon is 12, molar mass of hydrogen is 1, so you divide, then you get these values. Then the next step is that you are going to divide to all by the lowest value. The lowest value here is 1 point, which is 1.725. That is the lowest value. So divide all through by the lowest value to get the mole ratio, which is 3:6:1. So for the element, that is carbon, hydrogen, oxygen, 3:6:1. So to get the molecular formula, the molecular formula is equals to empirical formula multiplied by n. So following the procedure, the calculation step, you will arrive at n equals to 1. Then you multiply your empirical formula with 1, then you get the molecular formula to be C3H6O. Okay, thanks for listening. Next video, I'm going to show you more example on empirical formula.